That is, scientists who wondered about possible internal damage in the 88-foot-long Mesa Arch at Canyonlands National Park, one of more than 2,000 sandstone arches in 2 national parks in that part of Utah, now have an answer. They learned by employing seismometers to hear the arch's natural humming, then monitored the sounds for telling changes. Their report was recently accepted for publication in the journal Geophysical Research Letters. Basically, people were always asking if the massive stone arches were going to fall. There was reason for that, too. The majestic arches have stood for thousands of years. In 2008, Wall Arch, which spans 71 feet, collapsed suddenly along a popular trail. In 1991 and 1995, another arch lost portions of rock. About 43 arches have collapsed since 1977, according to rangers at Arches National Park, in a release. In response, University of Utah researchers including Jeff Moore placed 2 small, handheld seismometers on and near the arches for 1-hour increments. This is a tactic used to monitor the health of buildings, bridges, and other engineered structures, the release noted. The scientists know that the arches are being plucked by the wind and Earth's vibrations. Each movement has its own tone or frequency that shows up on the seismometer. Once the researchers had identified the standard tones, they were able to listen for any unusual sounds, said the release. If the resonance properties change, there is some change within the structure, said Moore in the release. We show that yes, this method works. The arches are really good resonators, so we can measure them and track them over time as a measure of structural change. For instance, Mesa Arch has 4 main sounds that result from its vibrations: bending sideways, moving in an S-shaped sideways jiggle, shifting up and down, and a wave-like movement the length of the arch. The team checked Mesa Arch's music over a year and a half and found no permanent changes that would show damage. As for short-lived changes in sound, they deduced that those resulted from temperature change on the rock surface, the release said. The researchers have begun to study other arches in the area, and say the technique could be used on coastal seamounts like those along the U.S. Pacific coast, natural bridges, pinnacles, and other rocks, the release noted.